Okay, lesson 6.2, real applications of the normal distribution. So what's new today is that we're going to be dealing with values that where the standard deviation is not 0. So that's why I said we're shifting away from 0. So kind of the non-standard approach here is that mu won't be 0 and the standard deviation won't be 1. There's going to be basically two types of problems. You're going to find the probability given a range of values, or they're going to give you the range of values, the percentage, and then you're going to find the z-score that corresponds to that. All right, so here's the kind of important formula that you're using during this unit, and it's how you go between your z-score and your particular x value that you are given, whatever number that is, based on the mean and the standard deviation. All right, so here is our non-standard 6.2 graph. And here is our standard graph, right, with 0 in the middle, and then some value you're looking for, x, right, area. All right, the basic ideas are, number 1, start off always with a little sketch of the area. Number 2, use the formula, whichever way you're going, left or right, okay? And then finally, use technology to find the percentage, or the z-score, because sometimes they'll give you the percentage. And I'm going to start by using the tables. It's kind of easy to do that, but you should also be able to have some sort of tech, whether it's your calculator or a spreadsheet, to be able to look those values up. So our first example here. What proportion of men are taller than 72-inch tall shower head? So in a bathroom, shower head installed typically 6 feet above. And obviously not all men, or women for that matter, are underneath that. So what percentage of the population are we ticking off by installing it at 6 feet high? So here's the graph that we need to begin with. Here we have our average height, which is going to be given to you. You don't need to come up with a 68.6 or the 2.8 standard deviation. So again, 68.6, and we know 72 is to the right. So we shade in the area that is to the right. Those are the people that will be irritated. All right, and that we call step 1. Just a simple sketch. Step 2, we now need to find the z-score that corresponds. So we take 72, subtract 68.6, divide by the standard deviation, and that gives me a z-score of 1.21. So now I'm going to go to my table and look up 1.21 in the table. I think it's here somewhere. All right, here we are. So here's a complete table that I found. I think I put one online too. And so 1.21 should be, I can't really highlight, but hopefully you can see there in the table. 1, 2 on the left side under Z. And then if you go over 2 columns, you see 0.8699. Okay? So we then write that down, 0.8699. Now if I go to my calculator or spreadsheet, that's what I'm going to do next. I'm going to get 0.877. So I go to my calculator, and we can see here I've typed in a formula. You can see on the bottom left corner, 72, 68.6, 2.8, and then always type in a 1 at the very end. That just tells you're giving a cumulative total. So in cell 1A then, yeah, I have the percentile of 72.8877. So notice the values here are slightly different between the two, right? A little bit more accurate on the computer. Now when I type those in, again, 88%, I need to find the complement. Remember, because we're doing not the left side of the curve, right? We're not doing this, the 88%. We want the other. So that's why we're doing 1 minus. So they both give us relatively close values. And in the table info, it's going to be 11.3, whereas in technology, you'll get 11.2. So we summarize then that about a little bit over 10% of the men are going to be ticked off when they bump their head in the shower. Example 2, U.S. Air Force requires pilot heights to be between those heights, 64 and 77. What percentage of women are in this range? Here's our women average. Here's our women's standard deviation. So again, I'll draw my graph. There's 63.7, 64, and 77. So now I see I'm going to have to find two boundaries. Okay? And then like this boundary is going to give me this percentage. And when I find this one, I'm going to get this percentage. And then I'm going to subtract those two. So step 1, I need to find my two z-scores. All right, well, the first one, remember, it's 64 is the minimum, and then 63.7 is my mean divided by 2.9, and then 77 was my largest height, and so I get these two z-scores, 0.10 and 4.59. Now again, off to technology. So we type in 0.10, I get the left hand, the cumulative, is about 54%. The right hand is way out there. This is 0.9999. Nearly 100% of the women are below that. Subtracting those two gives me, this is the percentage of women, again, that are now between those heights. So about 45.9%. All right, tips. Number 1, always sketch. It helps you understand, it makes sure that you're finding the right piece. Z-scores are not the areas. They help you find the areas, and the areas are not the z-scores. Pay attention to which side of the tail you're trying to find. And don't forget, negative scores mean z-scores are to the left, but negative areas are not possible. So don't ever answer a negative probability, right? That would not make sense. Now, if we're going the other way, that is, you're finding the values based on the areas, aka the probability. Still sketch, use the technology or the table, and then use your z-score formula to convert back. So a couple of examples here. U.S. Air Force wants to allow 95% of the women to apply. What would the new requirements for the heights be? So again, we're reversing this, right? We're not going with the 45. We're now looking, okay, if most of the women should do that. So then I draw a picture. Here's my average height. And again, I want a value out here that would accommodate 95% of the people. All right, step 2. We're now going to use a table to look up 0.950. All right. And so here we go. I'm looking for the 95th percentile. And hopefully you can see in 1.6 row, which is white, yeah, you have to go over 0, 1, 2, 3, 4. So between the 4th and the 5th column, we see that 9495 and 9505. So therefore we can split the difference. And we're going to say 1.645. Okay, using that table. Next, step 3. I now use my table, my formula, sorry, to calculate what is the x value that's going to generate that z-score. So multiply, add, right? Bam, 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 bam. So 68.4705. So if I want to allow more women to be pilots, we need to say the requirement of at least 68.5 inches. And the question is, could you be any particular height, below that? And technically, this problem is more complex because you can't have incredibly short people, otherwise they don't reach certain levers inside of an airplane. Men or women. So that's why we have a higher and a lower, because you got to physically fit in the thing. One final reminder here from chapter 4. What was significant? And we decided that if you are significantly high or low, you are less than within the 0.05. So again, what that means is that as I look at my standard deviation, if you're out here and out here, those are significant. So pulse rates that are significantly high or low for women, we're given the average, mean, and the standard deviation of pulse rates, beats per minute. That's what BPM stands for. So step 1, there's my 74. Here's my upper and lower table, and again, I want to know what these are. First of all, we got to find the 5% in the table. Well, we got to find the two tails too, I guess. So I'm going to take 0.5 and 0.95, and then these are my corresponding z-scores. Okay, and that is from the table or technology. All right, and again, if I go over here, I think I did this one here. Yeah, so I typed in a formula, and all these formulas are a little bit different. You got to figure out which one you're working with. If I want to do an inverse, where I know the percentile, notice I typed in normal. And by the way, you can just like double click and you start with that equal sign, and then you just type norm, right? And there we have a bunch of them to try. And you got to know which one it is. So the one I'm using here is norm S inverse. All right? All right. And that gives us, see, norm S inverse, 0.95. And that gives me the z-score for the 95th percentile. So I don't have to look it up in the table. And then the 95th percentile is going to be the reflection of that, right? There is symmetry, so these two here like depend on each other because these two are 5% from the ends. So now I go to my z-score formula and I type in those values. I solve for x. And so then we get, here is what would be considered significantly low and below that. And then this is what would be considered significantly high. Best of luck as you do your homework.